set, paper 2, mathematical literacy. Question 1. Soccer City Stadium, also known as FNB Stadium, is one of the stadiums in South Africa used to host big soccer games. Next year A shows the sitting layout of the Soccer City Stadium in Johannesburg. Use the next year A to answer the questions that follow. State the view represented by the sitting layout plan of the stadium. This is the stadium, the view that we are seeing. This is the top view. You can say it's a top view. Or the bad view. All right. The capacity of the stadium is 88,000 spectators. Explain the concept capacity using the context. So we are saying is the maximum number of spectators in the stadium. Simba wants to enter the stadium using entrance 12. Write down the name of the road that passes next to entrance 12. Entrance 12 is this one here. So we have what? Nesrek. Nesrek Road. Write down the number of ticket clearing points and entrances separately into the stadium. So the ticket clearing, we shall come on the map and we see these are the ones. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, then we look at the entrances. Entrances we have 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So here we got it as 9, then the entrances we have 19. The organizers sold 85% of the tickets for the match played in the stadium. Calculate the number of unoccupied seats now. If 85 are sold, that means you're left with 15% times the capacity. And the answer was supposed to be 13,200 seats. The Central University of Technology wants to replace the old student desks in their student accommodation centers with new ones. Annexure B shows the item list that comes in the box of the student's desk. Use Annexure B to answer the questions that follow. Let's come here to next step B. These are the list here. Determine the number of washers needed to assemble the students' desk. You come here, these are the washers. You have the flat one and the spin. So these are 8 and these are 9. There's no any other washer around here. So we shall say 8 plus 9, you get your 17. 17 washers. Give one reason of give one use of the student desk to hold or carry the study material. Someone else would say it's used to study. Used when writing. Write down the item using a symbol from step 2, which is not listed under the list. Take note, here we have F, A, D, E, B, C, H. And come step 2. This one is missing. G is missing, so we shall write there. G is missing. Write down the number of screws used to attach the top unit in step number 3. Number of screws in step number 3, we shall count them. Here we have 2. These are 3. We have 3 here. We have 2. So they become 10. Screws. One apartment has 4 rooms. Calculate the number of new desks needed for 15 apartments. If one desk is placed in every room, so we are saying 4 times 15. The answer becomes 60. 1.3. Calculate in inches the total length of the upper part of the stand. Total length. So here it is. Look at the total length. So we have 27. Or length, sorry, not height, length. We have the 44 plus the length. So it's going to be 44 plus 20, and the answer becomes 60 centimeters. Which color of the stand that the student bought? We are saying it's what? Gray. Why do we say it's gray? We look here, the foldable laptop stand, and the color is here inside the brackets. Explain the phrase no assembling required. We can say it's already ready, or we can say no unattached parts. Unattached parts. All parts are attached together. Convert the maximum height of the deck to millimeters. Maximum height 27 here. We need to become millimeters. So centimeters to millimeters, multiply by 10. So it's 27 times 10. Answer became that much. Number 2, it talks of Mr. Labushan. Okay, an athlete with disability staying in South Africa traveled to Tokyo to participate in 42-kilometer Paralympic marathon. Then athletics participated in 3 groups: T1, T12, T146, T54. Annexure C shows a route map of marathon from the start to the finish point. Use annexure and the above information. Use the information above and the annexure C to answer the questions that follow. State the general direction. Of Tokyo Sky Tree from the starting point. Remember, we are from the starting point. So let's go to the next year. Starting point. The starting point is this one here, this point here. So you draw a compass there. Where is this sky? Oh, the sky tree here. So which direction are you tending? So we shall say it's north, east. So the answer is, or someone can write that. Write down the probability of selecting a group of men and women participating in the marathon. Give your answer as a fraction. A group of men and women. Let's come to the next year. The groups are here. Men and women. This is it. We have 1, 2. Out of how many groups? 1, 2, 3. So the probability there is supposed to be, it's 2 out of 3. 2 out of 3. 2.1.3. After completing his training in South Africa, Mr. Lamia stated that he would be able to complete the marathon in 2 hours and 33 minutes. State 2 possible factors that may affect his running pace. 1, we have what we call the weather. Then also the nature of the place where he's going to run from. It might be a hill, yet he was just running around. It might be hilly that side, right? Okay, 2.1.4, write down the name of the station which is situated at 15 kilometers mark of the marathon. We come here, we look for 15. That's the first thing we do. 15 kilometers. This is 15 kilometers. So the station is supposed to be, the station is Asakusa station. Asakusa station. Calculate how many kilometers will be left before reaching the finishing point when the athlete is at 40 kilometers mark. Let's go there and we see. If the athlete is here, what will be left to go to the finishing line? Remember, in the scenario they told us, the marathon will take, it's a 42 kilometer. So if the person is at 40, how many are remaining? 40, which becomes 2 kilometers. Write down the number of the U-turns shown on the map. U-turns shown on the map, we have 1 here, 1. We have 2. Then we have 3. We don't have any other 1, 2, 3. So we shall come here and we say there are 3. All right, the information about the different groups of participants participating in the marathon with starting time was provided on the internet. Give a possible reason why different groups start different times. One position will be they have different disabilities, differences in disability. Then part B, There were 3,960 athletes on the day of the marathon. Group T12 had 1,700 athletes and T54 had 1,580 athletes. Write down in simplified form the ratio of the three groups. Remember, we have T12 of T of 6. So we've already seen that this one has 1.7 and this one had 1.58. But they have told you when they added them, there were 3,960. So this part is missed. So we shall come here, subtract this, that. I believe you end up having 600. So we've got this missing value here. 680. This one becomes 80. So here by 2 you remain with 34. By 2 you remain with 79. And by 2 you remain with 85. So this is a simplified format that we needed. One is 3 marks. This one was missing. That one was missing. All right. Question number 2.2. We have a map that we see here. All right. Then write down the number of nature reserves appearing on the map. Nature reserves we have 1, 2, 3, 4, 5. So the answer there becomes we have 5 nature reserves. Write down the name of the province situated in the northeasterly direction of Edinburgh. Northeastern direction. We're looking for the name of the province situated. So northeastern direction, which province is in this direction? Pumalanga. You see? Eastern direction. So the only province that we have there is Pumalanga. So the answer here becomes Pumalanga. Pumalanga. Basically, I wanted to check the distance from Edinburgh to Bloemfontein. He used the distance calculator on the internet and discovered that the distance between the two places is 77.5 kilometers. Calculate the distance between the two places using accurate measurements and the scale provided. Give one possible reason why the calculated distance and the one on the internet do not match. So one, when I measured the distance I got, it was 66 millimeters. All right. Then I have to measure the scale which is a bus scale. So a bus scale, it's from 0 to 60. 0 to 60. I also need to measure it. So I ended up having 3 centimeters, equivalent to 60 kilometers. So I might ask you, we are looking for what's the guide to this, so we shall divide this. This is 6, because I need centimeters now. M6,6 divided by 3. The distance got here, it was 132 kilometers. Question number 3. Question number 3. Question number 3, it asks us to look at this. All right. A farmer in the United States of America uses the containers below to store and supply milk to local factories. The first one, when you look at it, this is a rectangular prism, and this is a cylinder. All right. It has this much capacity, and this has this much capacity. All right. Let's go deeper. We are saying, they are telling us convert 55 gallons to liters. All right. What do you do first? Ask yourself, 1 gallon is equivalent to this much liters. Or you have 55. That means you're going to multiply by these are liters. Write down the two dairy products that can be produced by using milk. Are we looking at yogurt? We can also look at cheese. We have amase, which is rotten milk, sour milk, sour milk. What else can be produced from butter, which could be margarine, butter. And it's what we call ghee. It's more like cheese, but it's not cheese. All right, those are products of milk. Any two. All right, there we go. We have show through calculations that IBC Tonte can hold more than 310 gallons. You may use the formula as this much. First and foremost, we are looking at what we call volume. This is what, when I look at it, this is what I look at. Anyway, and we need to change the units to. Let me do the question. I'll be doing question number 3 next to the diagram. So we look at question number 3.1.3. We're looking at volume. But before you look at volume, these have to be turned into centimeters. Why? Because the conversion that we are using, it will have this one here. It's what we are going to use. So 1 inch is equivalent to 2, so here, these ones are all going to multiply by 2,54 times 2,54. We change inches to, we change inches to cent. Okay. Then 48 times 2, 92. 40 times 2,54. We have 101,6. Then 46 times 2,54. We have 116,84. So all these are centimeters now. And now we are into times what? Height, which became times. So the volume they will become so here we have the answers 10,300 cubed. All right, we make them liters. We divide by 1,000. We divide by 1,000, you remain with 1,400. 1,447. 1,447, 31. These are liters, but we want them to become gallons. What do? We shall divide this by 4,5. And we end up having gallons. The statement is true. All right, we go to question number 3.1.4. The farmer decided to paint the total external surface area of a drum to keep it away from rusting. The spread rate of the paint is 2,5 meters per liter, and the paint sold in 1 liter tins. Calculate how many tins of paint will be needed to paint 1 drum. This is surface area. So what we are going to do, we are going to substitute into a formula. So also allow me work it around the near the drum that we are looking at. Now, another thing we have to know, the question talks of meters squared per liter. Understand? So our measurements have to be in meters, not inches. So we need to change that. So remember, we are looking at surface area of a cylinder, which is the same as H. So our radius, it has to be found, which becomes 11,25. Then the height, it has to be changed to centimeters, multiplied by the height, which is 33, multiplied by 2,54, 2,54, whereby we have 33 times 2,54, 2,54. All right, then we've changed the height into centimeters. Let's see that. Actually, we need also to change it back to meters. So 33 times 2,54, we end up having this much, which is 83,82. These are centimeters. We divide by 100. We end up having 0,84. These are meters now. So we do the same for the radius, which is 11,2 times 2,54. I change them. So the radius now, these are centimeters. We want them to become meters, divide by 1,000. Question number 3 goes, a farmer in the United States of America uses containers below to store and supply milk to the local factories. We have the first one here, which is a rectangular prism. This is a rectangular prism, and this other side is a cylinder. Then we go on and they say, convert 55 gallons to liters. Round off your answer to the nearest whole number. So now, gallons, if you only have 1 gallon, you have this much liters. So if you have 55, what will happen? To be 55 times 4,546,092. So when you multiply here, you end up having, you have the answer as 250,04, but they say to the, which is 250 liters. Then we come right down the 2 dairy products. We are saying we have yogurt, then we have cheese, things that are good from milk. We have sour milk. They also produce what we call margarine, or we can say butter. There's one that's called ghee. It's used to make food. Okay. These are all products from milk. You can add on any that you know. Show through calculations that the IBC thought A can hold more than 310 gallons of milk. So, first and foremost, we are going to go up there. These are gallons. And the measurements we have here are in inches. And for us to get gallons, we shall have to deal with liters, not inches. So what we need to do is to change the units, to centimeters, which will be easier for us to do it. So let's come here. We change the units to centimeters by multiplying by 2,54. We just need to multiply by 2,54 throughout. We want them to become centimeters. All right. Then when you multiply that, you end up here. You end up having 121,992. Here we have 101,60. And we have 116,84. We have changed them, all these now are in centimeters. So we go ahead and we look for the volume now. The way you see it, it's a rectangular prism, so its volume will be volume will equal to L times B times H. You see that? We are dealing with this. We are dealing with this. So we are saying volume. So our length is 12,192 times 1,60 times 116,884. When you multiply this, you shall get the answer. This will be in centimeters what? Cubed. Centimeters cubed. When you multiply there, you get the answer as 1,447,305,9. These are centimeters cubed. Divide by 1,000 to turn them into liters. You remain with 1,000. 1,447. Now, these are liters now, but you are interested in gallons. You are interested in gallons. So what happens? The gallons, we shall change them, we shall change the liters to gallons by dividing. We divide by this amount of, because these are liters, so we divide by 4,546,092. And we end up having the answer as 318 gallons. And indeed it's valid. Actually, they said sure, so it's not to verify. You don't need to verify. Let me write it properly here. We are saying we had changed now the length. We've changed everything to centimeters. Why? Because it would be easy for us to change to liters. So we changed the inches. The length was 121,92 times 110,6 times 116,84. So here we ended up having 1,447,305, these are centimeters what? Cubed. So how do we change them to liters? We divide by 1,000. And that brought us to 1,447, 31. These now are liters. But we want to change them to gallons. So we divide by 4,54609. And the answer became 318. These are gallons. These are gallons. Remember, they're saying sure. Okay, we come to the other question. 3.1.4. The farmer decided to paint the total external surface area of the drum to keep it away from rusting. The spread rate of the paint is, take note of that, the spread rate is given in meters squared per liter. Can the paint, okay, and the paint is sold in 1 liter tin. The paint is sold in 1 liter tin. Calculate how many tins of paint will be needed to paint 1 drum. So what we need to find out is the area, surface area. When you look at the drum, what is the surface area for the drum? The drum takes on a cylinder, part of it, and initially we know very well that the surface area of a cylinder is 2 pi r squared plus 2 pi r h. This is the formula. Why do we have 2 pi r squared? Because this is the area for the 2 circles, one on the top and the other at the bottom. These are circles. And this other space now that's remaining, it's this formula here. Anyway, let's look at what has brought us today here. It's to look for the surface area. The surface area that we're going to look at, it has to be in centimeters first, actually meters. Why? The formula or the spread rate is in meters squared per liters. If you remember this, what I highlighted here. So we can't have centimeters squared there. So what we're going to do, we shall change inches to centimeters and centimeters to meters, which is going to be so simple. We shall say this is 22, which is the diameter. We multiply it by 2,54. What are we doing? We are looking for centimeters. So 22,5 times 2,54, we end up at 57,1. So we divide this by 2. I'm looking for the radius now. 57,15 divided by 2. I've got my radius as 28,56. These are centimeters. I want them to be meters. I divide by 100. And I divide by 100, I remain with 2,856. These are meters. Put it aside. What about the height that we had? The height was 33. Also change it. Now the height will become 33 times 2,54. 33 times 2,54. We have 83 now. 83,82. These are centimeters. I want them to be meters. I divide by 100, and I will end up having my 0,8382 meters. So I've dealt with now everything. Now it's in meters. What do? I go ahead and substitute into the formula. Remember the formula we are going to use. It's 2 pi r into r plus h. So it's 2 times 3,142 times the radius, which we already got as 0,2856. Open brackets, the same numbers. That's the scenario, plus the height, which is 0,8382. So here we end up doing that. Here we go, we see this is much. So we end up having 2,01 meters squared. So how much paint? That's what we are looking for. How much paint are we going to use? So how much paint are we going to use? We shall see. We shall divide this by 2,5. The spread rate, which will give you 0,28. Two 0.0882 liters. So this is how much paint that's needed. It simply means it's only 1 tin, because this one does not treat it a liter. So you buy 1 tin, and we go like that. Okay, how many tins of paint will be needed to paint 1 drum? They are saying it's 1. Okay. 3.2, question number 3.2. The farmer checks the weight of the cow once per term to make sure that they are healthy to produce enough milk. He uses a manual way of calculating the weight by measuring the cow's girth and the body length. The girth is the measurement around the middle of the cow. Choose the most accurate tool from the ones listed in the brackets. The farmer may use the measuring tape / ruler to measure, to measure the girth and the body body length of the car. He has to use a measuring tape because a ruler it's not good at carving. Okay, show through calculations that a cow with a girth of 70 inch and a body of length of 78 inches weighs 577.88 kilograms. What we're going to do, first and foremost, substituting the formula here. The girth they've told us it's 70. You square. The body length is 78 over 300. Over 300. So you end up having this much. But remember, this is in pounds, LB. We want the answer, we want to compare it with kilograms. So if 1 kilogram is equivalent to this, what about these pounds here? So we need to divide this by 2,204. Indeed, here we have the answer as 577.88. Don't forget. Remember they said, show through calculations. So now you've shown. Show through calculations. All right, we look at question number 4. Question number 4. Question number 4, it talks of a team of netball players from Jacobsdale Agriculture School with their coach traveled to Cape Town to attend the Netball World Cup final match. Due to the unavailability of accommodation in Cape Town, they booked a hotel in Pearl. A map on an extra day shows the distance in kilometers from Pearl to Cape Town and surrounding towns. Use the information above and use the information above and an extra D to answer questions that follow. 4.1.1. All right. In 4.1.1, what do they want us to do? They want us to write down the name of the town that is closest to Pearl. Let's look at the next chapter. All right, here we go. Wonderful. When you look through very well, Pearl is here. All right. So they're asking us, where is the nearest? The nearest. So Pearl to this place here, it's what? 25. To this place here, it's 60. To this place, acres, it's 50, you know? So the nearest town is this one here. So we shall go back and rewrite. The nearest town is Franschek. Okay, question number 2. On the day of the match, the team with their coach left the hotel at 8:30 in the morning. They traveled to the waterfront mall where they had their breakfast. It took them 1 hour and 7 minutes from the hotel until they left the mall to Cape Town International Convention Center netball courts. All right. Write down the time that they left the mall. Write down the time that they left the mall. Remember, they left the hotel at 8. So they spent 1 hour and 55 minutes. So we are going to only add. So we say 8:30. When you add that up, that means they left at 10:27. This is still in the morning. 10:27. Calculate the average speed in kilometers per hour of their vehicle from Pearl to Waterfront Mall. So we're looking at the two distances. If it took them 58 minutes to travel to Cape Town CBD. So we need to know, first and foremost, we are looking for calculate the average speed. When you look at the formula given to you, so there's no speed anyway. Remember, we use the triangle there. We use the triangle which says speed, which says speed equals to distance over time. The triangle that looks like that. So we need to change the formula. So the formula becomes speed equals to distance over time. So ask yourself, do you have the distance? Ask yourself, do you have the distance? Let's go and look for the distance. So they are from Pearl to Cape Town. So to Cape Town. So that means they have to travel 36 plus 25. We are looking for the distance. You see that? So a mere moving from Pearl to Cape Town, they have covered this distance, which is approximately 61 kilometers. But then from there, waterfront to Cape Town CBD, it takes 2 kilometers. So here we add on the 2 kilometers, so which becomes the total distance. Here we have it as put it aside. Remember, so we have the distance as 63. Distance, we've got it as 63 kilometers. What about time? Time, they spent 58 minutes. Let's go back and analyze. So 58 minutes plus the 7 minutes, which becomes 1 hour and 5 minutes. 1 hour, 5 minutes. So this has to be changed to hours because the speed that we need is going to be kilometers per hour. So how do we change that to hours? We shall divide. So it means it's 58 plus 7 is a minute. 58 plus 7, you end up having 65. When you get 65, you have to change this into hours. Divide by 60. Divide by 60, which is 60. So we end up having time was 1,08 hours. So you're good to go. You substitute the formula whereby we shall say the distance is 63 divided by 1,08. So 63 divided by 1,08, the distance or the speed was 58,33 kilometers per hour. Kilometers per hour. All right, we go to the next question, 4.1.3. The school arranged a friendly match between their team and a high school in one of the towns around Perth. Use the directions below. Write down the town where the match took place. From Perth, they traveled 25 kilometers to, so from here, they traveled 28 kilometers from to the T junction. So they turned right. Their destination was the first town from the T conjunction. Now, we have to look at that and see. They stayed here. They moved 25 kilometers to this place here. They continue 28 to the T junction, which is this. Then remember they are moving, coming downwards. That means this is their left, this is their right. So they turned right. What was the nearest town up? It's what? Gwarimbo. It's Gwarimbo there. Oh, it's called Gumbo. That's the town they will meet. All right, we go to question number 4.2. The table below shows the accommodation arrangements for the team and their coach. The rates given for one night only. The team arrived at 5 on the 5th of August and checked out at 8 on the 7th of August. They traveled with 22-seater bus with a fuel consumption, which has a fuel consumption of 10.5 liters per 100 kilometers. The total distance or return trip was 2,769.2 kilometers. Here we go. Write down the total number of players. Now, the total number of players, here we go. We had to look at this. Three times 4. Then this times 2. Plus 1 times 1, which is what? 12 plus 8. But players, remember one was the coach, so they are 20. It's 20 players. Then explain the meaning of round trip as in the context. It means is what we call the return. Return what? Return trip. It's to and fro. 50% of the total amount for accommodation and petrol will be paid by the school governing board, it's the SGB. And the other 50% will be shared equally amongst the team members and the coach. Show through calculations that each member will pay 1,269 rand 78 cents. First and foremost, we need to know how much are they going to spend. 1, on accommodation. 2, on petrol. So accommodation, as you see it, this is rates per room per night. How many rooms did they take? They took 3 rooms here. So it will be this much times 3. Then here we go. How many were there? There were 4. And this is 1. So what I've showed you there, it's going to be 3 times 2, 2,000. Then you add on the 4 times 2,000. Then plus the one from 3 times 2,800. We have it as 295 plus 3,200. So 8,44 plus 11800 plus 3,200 So this became so this is my, but remember, this is only one day. So we multiply it by 2. We end up having 40,000, sorry, 46,800. This is accommodation. Then let's go to the fuel. Fuel, we are going to look at, this is what? Accommodation. Let's look at the fuel. Fuel, we need to know how the car, okay, the distance covered, it's 2,000. Remember, the car has a consumption of 10 is to. So simply meaning for every 10,5 liters, the car covers a distance of, but the distance being covered here is, what? 2,769.2 kilometers. So how much petrol shall we need? So it will be 100 times the unknown equals to 10,5 times that much. So we divide through by 100. Divide through by 100. So here we end up having or knowing how much petrol do we need, which gives you 209, these are liters, but each is 200. So when you multiply this, you end up having 6,530, 60. So add the 2, divided by 2, 48 plus 65. So we have this much. We divide this by 2 because 50%. So you end up having so this is what we are going to divide. We are the 21 people. Person has to contribute to that. Question 4.3. The table below shows the weight and the height of the netball players. The information is used by the coach to select the appropriate position for each player. Write down as a percentage the probability of randomly selecting a player with the height less than 170 centimeters and the weight of 60 from all the players. First of all, there's no one with 860. So here the person becomes 0%. As a percentage. Determine the weight status of a player with the height of 188 centimeters and a weight of 8. So this has to be in meters. Divide this by 100 and you have that much. So this is in meters. So they're asking us, so the mass is already 80 divided by 1,8 squared. So you get it. So the person is 22,63 is a kilograms per meter squared. When you look at this, in between 18,5 to 24, the person is what? Normal. So the status here becomes what? Normal. Normal. All right, we got to question number 4.3. Table shows each player has a specific playing area to play during the game in. Table 2, the playing areas or playing position are shown. So they go ahead and ask you, write down which players may not play in 4 and 5. Four and 5, we have main players, the shooter, the goal shooter. You know, their numbers are not, the 5s are not there. So it's goal shooter and the goal attacker. Goal shooter and also, take note, let's take note, a clear note. Also the center. So the center is not supposed to play there. So, show through calculation that the difference between the radius of the goal circle and the radius of the center circle is 4,4 meters. Let's come and say this is already in meters. We don't need to change that, but then we need to change the 900 into meters. We divide by 1,000, which becomes 0,9. So we're looking, this is the diameter, we're looking for the radius. We divide this by 2, end up having 0, we have 0,4. So we need to the difference. So we're going to subtract, which is 4,9 minus 0, and indeed it becomes as they told us to show. All right, they're telling us calculate the area in a meter squared, the area of the netball court. The area of the netball court. So they want everything. It's a rectangle. So the width is already there, 15,25. 15,25. Then the length is going to be, the length will be 10,7 times what? 3. So let's see, the length now becomes, so now the area, the length, when you multiply that by 3, 10,17 times 3, we ended up having 30,51, and this is the length, and the width will equal to 15, substitute in the formula, and the answer becomes 465,28 meters square. Number 5, question number 5. Mr. Batman is a businessman who owns a printing company. He bought a 2-bedroom house and turned it into an office. Annexure E shows the floor plan of the house he bought. So let's give that. So they're asking us, give one reason why the plan is referred to as an open plan. The reason why for an open plan, we usually don't have walls. The reason is no walls between the kitchen and the living room. That's why you call it an open plan. No walls between, no walls. When you check this, you see, here, would have a wall here, and probably would have a door somewhere here. So now this one is not there. So it's open. Someone in the kitchen can see whatever is happening in the living room. Someone in the living room can see what is happening in the kitchen. The walls are just on the bedrooms. This is why it's called an open plan. All right, we go to the second question. 5.1.2, write down the probability of randomly selecting a window on the western side. Western side, when you look at our campus, the western side now, this is it. This is east and this is west. So on the west, there's nothing like a window. The probability there is supposed to be 0%. Mr. Batman wanted to change the master bedroom to a boardroom where he could hold meetings. He removed everything so that he could change the following of the room and use carpet tiles. All right, these are the costs, or these are the so we are continuing and we are saying, look at these values, which is carpet glue, 5 liters for every 3 meters squared. One tin has 5 liters of glue. The carpet glue price is 359 per tin. The carpet tiles, it's 550 per meter squared. Then the cost of labor is 400 per meter squared. Calculate the number of 5-liter tins. Calculate the number of 5-liter carpet glue tins that Mr. Butter must buy to cover the whole room. Now, first and foremost, we need to know the area. First and foremost, we need to know the area to be covered. Area to be covered. So we shall go in the room and you see is renovate this. So we look at what are the dimensions. The dimensions of the master bedroom are 3 meters by 3 meters. So meaning the area here is L times L, which is 3 times 3 and became 9 meters squared. So we are determining the 5-liter. So the 5-liter carpet glue. And they have told you only 5 liters. They cover an area of 3 meters squared. So for us, we have how much liters shall we have? So we divide it through and we find out to be 9 divided by 3. So we shall have to buy 5-liter tins. 5-liter tins. Determine the total cost of installing new flooring. So now he's going to buy the glue, 3 of them. So it's going to be 3 times 359 plus he has to pay for the tiles per meter, which is 550 times 9 plus the labor 400 per meter squared, and they are 9 meters squared. So this is how we come up with the answer. So here we have 177 plus 4,950 plus 3,600. So here it will equal to 9627. This is the amount of money the person will need. Okay. We look at question number 5.2. Bedroom 2 will be used to store boxes of paper for printing purposes. As shown in the picture below, 20% of the space on each side will not be used, allowing movement when packing and unpacking the boxes. So this space here is not going to be covered. This space here. So that means the shelves are going to cover the space. Only this one here. So we shall need to know what are we going to deal with. Okay. Now they're asking us. One of the employees said that they would be able to pack 7 layers of boxes in the bedroom. So what we're going to do, 7 layers of it, that means going upwards, which is going to be the height of the room divided by the height of the box. Why? Because you're going up, you're looking for layers. So we shall come here, they have told us the height of the wall is 2,4, which we wanted. This is 2,4. These are meters divided by, what's the height of this? Divide this by 100, make it meters, which becomes 0,318. Come here. 0,318. So we divide, and indeed we get 7, which is 7. So the validation is, the claim is valid. The claim is valid. Look at the last question. Calculate the maximum number of boxes that can be packed in the bedroom if the boxes are packed lengthwise. Lengthwise along the width of the room and width of the box along the length. So simply meaning when they bring the rims are going to be packed like this in the long method. Yes, sir. So the length, so this one simply means the width of the room is going to be divided by the length of the box, and the length of the room is divided by the width of the box. So here we need to analyze and understand what we are dealing with. So what's the width of the room? We shall come here. The width of the room is 2.6. The length is 3. The width is 2.6. But 20% has been removed. What do you remain here? The width, the room is 2.6. 20% has been removed. That means you're remaining with 8%, which is 2.6 times 0.8. Remain with 2.08. So these are meters. Then what about the length of the room? They've told us it's 3. If it's reduced by 20, you end up having 2.4 meters. You see that? Then the layer, we saw them already, they are 7. So here it's going to become 2.08 divided by, remember you divide by the length of the box, and the length of the box is, turn it into meters, 0.28. This divided by 100 also, 0.23. And this we already have it here. So let's come down and say so this one here is going to be divided by 0.28 and 2.4 is divided by 2.4 is divided by 0.23. The layers we've already seen height of the room divided by the height of the box. So 2.038 divided by 0.28, we have the answer 7.42. And the final answer here is 7 boxes. Whereas 2.4 divided by 0.23, we have the answer as 10.43, which is yes, the layers we already saw them as what's the maximum? We shall say that. Thank you very much.